Do you have a battery going dead on your vehicle overnight, or a customer brings in a vehicle that says my battery's going dead and you're not sure how to tackle it? Nuts and bolts with Tone here, guys, and today's video is about parasitic draws, how to diagnose them, how to isolate them, and figure out what the problem is. Now, before we get started, let's understand what a parasitic draw is. A parasitic draw is where something is drawing power like a parasite. It's drawing power when it should not. You turn your key off, and overnight, you have something that's staying on. It could be something as simple as the visor was left down with the light flipped on, or your glove box didn't shut, or you have a door ajar switch that's bad, that's keeping your interior lights on, and it's drawing power. Now, sometimes something very small like a glove box light or a visor light, they don't draw a lot of power, and sometimes it doesn't kill the battery overnight. But you can have things like maybe you have an air suspension problem, you have an older vehicle, and your air suspension has a problem, and it's causing your air compressor to kick on constantly, thinking that the vehicle is constantly sagging. And that's going to draw a lot more power. Now, how do we go about finding this? So there's a lot of ways to do this. So back in the day when I started 20 years ago, I remember the very first vehicle I ever had was a parasitic draw, and asked my boss, how's the best way to tackle this? I've never had this before. He's like, disconnect the positive battery cable and clip one end of a test light to the battery post and hook the other end into the battery terminal and keep the battery disconnected. So you're going to put this in between the two. And if this light bulb lights up, that means something is drawing power, and you got to pull fuses until the light bulb goes out. So that's how people used to do it a long time ago. Vehicles were a lot less sophisticated, and tooling was a lot less sophisticated. It was a lot harder to have the proper tools. So the tools that we're going to use in this video. So in my opinion, the two best ways to determine if you have a battery draw and how much a battery draw you have is the Power Probe Draw Monitor, PP Draw, and this guy right here. This is called a low amp probe. Now I'm going to explain to you why both of these are beneficial and why you want both. Now, this works on just about everything except for sometimes battery cables, you just can't quite get in that hole and get it to close. If that does not close, it's not going to read properly. So what this does is this determines how much amperage is passing through a battery cable. So what I like to do is put this on the ground cable because it's the easiest to clip onto, and it will give us a number there, and it will tell us how much of an amp draw we have. Now, anywhere up to a 50 milliamp amp draw is acceptable. So 0.050 amps or 50 milliamps. The Power Probe Draw Monitor is a little bit different. This one, we're going to plug right into the DLC of the car. We're going to disconnect the battery, and we're going to hit the button, and this is going to tell us what the draw is. So I'm going to create a draw on this vehicle. We're going to look at it with this. We're going to look at it with the low amp probe, and I'm going to show you another tool on how to find the circuit. I'm going to show you multiple tools that you can use to figure out what the problem is. Some of them are a little bit simpler. Some of them are more sophisticated. Before we get started, hit the like button, hit the subscribe button, and hit the bell. You get notified of all my future content, which you definitely don't want to miss. Let's jump right in. When does a Power Probe Draw Monitor not work? Well, here's where it doesn't work. I'm going to give you an example. So a Power Probe Draw, what it does is you have to charge it first of all. It has its own battery. What it does is it pushes power into the vehicle, and then it does its magic, and it looks for circuits to be alive. But now here's where it doesn't work. So I had a ProMaster that had a draw, and I plugged in the Power Probe Draw Monitor, and it said I had a draw of, I don't remember, like 1 point something amps or something. It was a pretty big draw. And anyway, so I started checking fuses, and I found this one fuse that had the exact same draw as the Power Probe Draw Monitor showed. So I started looking into this circuit, and I found out that circuit was the radio, the HVAC module, like about 5 or 6 modules in the dash. So I went and I sold a bunch of time to go chase these modules down, because when you have a draw like that, the only way to figure out what's drawing the power is by disconnecting. So let's say I checked the fuse and I found that I had this draw on this certain circuit. And let's say the radio, the HVAC module, and a few other modules are on there. Well, the way that you figure out what the draw is you have to go and disconnect the modules. So obviously the radio is the first one. You're going to disconnect the radio. If the draw doesn't go away, you're going to go to the HVAC module. And you're going to keep disconnecting modules until you find the draw to go away. Now, here's why it didn't work for me. On this specific vehicle, that circuit also fed the DLC. So the DLC's power was pushing in, and that was providing power to that fuse, which was giving me a false draw. I still did have that exact same draw, but I chased the wrong circuit. So then, before I went and tore the dash apart, I thought, let me double check this thing with my low amp probe. So I threw my low amp probe on the battery. Sure enough, I had the exact same amp draw. However, once I disconnected the PP draw, I did not have a draw on that fuse. I ended up finding an aftermarket hydraulic pump in the back corner of the vehicle that was actually drawing the power on this one specifically. So that's where it doesn't work, and that's why I said it's good to have both. The PP draw is great, but you also need the low amp probe because one is not always the best. You want both, you want to double check, and it's good to use both. That's why I said that. So step one in figuring out what a draw is going to be, we need to access the fuses. So in this car, there is a fuse panel right there. And there is a fuse panel right there. Now, some vehicles have a fuse panel on the passenger side. Some have them in the trunk. Okay, so what the most important thing is that we are able to access this with the door open. So in some vehicles, you have to flip the latch here to tell the computer that the door is closed. In this one here, it's a little bit older. We were able to just put a clamp on here on the door ajar switch. Now the door is closed. So now we're going to look at several things. So sometimes testing it is hard to determine on which battery cable you can get to. On this one here, the negative cable goes down behind the battery, so you may have to take the air box out in order to clamp onto the negative. What I like about using the ground is sometimes you can clamp on all the ground at one time, and it's going to tell you the whole draw for the vehicle. Versus this one, where there are two battery cables, two positive battery cables. This goes to an amp, but there's two battery cables, so you have to test each one individually. Now you can see we are at 70.7 amps, so 700 milliamps, and I told you that 0.050 was the limit. So now we're going to take the PP draw here and we're going to plug it into the OBD2 port. And we're going to turn it on. All right, so now that we've got the PP draw hooked up, we're going to hit smart output. Okay, and that's not going to tell us the draw rate, so we have 0 milliamps. That's because we need to disconnect the battery. So now, let's disconnect the battery. Now remember, we had 0.7 amps. So we can go ahead and disconnect this. We'll turn that off. Okay. Now let's go ahead and disconnect this battery. All right. This car might look familiar. This is one that we did a video on how to replace a starter on a Camry. All right, so now let's see what we got. Oh, look at that. So, by disconnecting the battery, we still have a draw. Now, remember when I said that a bulb wouldn't create a draw if it wasn't on? Well, that's because this operates in a different way. This doesn't look at what the vehicle is doing. So what this does is this pushes voltage into the vehicle and it looks for circuits that are on. So we have 717 milliamps. All right, so now we need to find that. And how do we go about doing that? Well, back in the day, the easiest way to do it is to start pulling fuses. You start pulling fuses until the draw goes away. You look at your amp draw there, you pull fuses, and when the amp draw goes away, it looks like you figured it out. Now remember when I told you that we had to wait for everything to go to sleep to determine if we had a draw or not? Well, here's the problem with pulling fuses. So sometimes when you pull fuses, you're waking things up. So like if you pull like a radio fuse, you're just pulling the radio fuse. But sometimes you're pulling fuses that are related to modules. And when you pull that fuse and you put it back in, that circuit wakes back up and that computer is awake now. So now your draw goes up a lot and you have to wait for it to go away. You have to wait for the draw to come back down. So that is why pulling fuses is not a good idea. Now I'm going to show you an alternative to pulling fuses. So another way to do it is to do a voltage drop. So a voltage drop is you are checking voltage across a component on one side and the other. So you're looking at how much voltage it's being lost through. So what we're going to do is we're just going to randomly, we're just going to go to this fuses here and we're going to check the fuse. And if I leave this on long enough, it will go down to almost 0 millivolts. So that means that there's no draw on that circuit. It's not drawing any voltage. Now what happens if, let's say we have like 4.9 millivolts? How do we know if that is the draw? So with using the multimeter, we find millivolts and we don't know if that is our draw. We know that we have a 0.7 amp draw or 718 millivolts of amp draw. But we don't know what that equates to as far as millivolts and fuses and things like that. And sometimes the draw can be two different things. So how do we figure that out? Well, we're going to go to PowerProbe's website and I'm going to show you how we can use the millivolts and we can translate that into amperage. But first, we got to figure out what is the problem. So I'm going to show you another tool to use. So after going through all the fuses in the car, I've made it to the inside fuse box here, and I'm checking this one fuse, and I've got 6.9 millivolts. Now I know it says negative, that's just because the leads are backwards, but so 6.9 millivolts. So now that we've got 6.9 millivolts on that one circuit, now we can go to the PowerProbe website and we can see what 6.9 millivolts equates to in amperage and if the two line up. Let's go take a look. All right, so what we did is we went to powerprobe.com. We just typed in PowerProbe fuse voltage drop chart. And we had 6.9 millivolts. So millivolts is in that category. And we have a 7.5 amp fuse. So we're going to come down this line right here. And we're going to come over from 6.9. So 6.9 is 636 milliamps. So that's about how much it is right there. So that is, we had about 700 milliamps of a draw, and that equates to 636 according to the voltage drop. So now let's check out a new tool by PowerProbe. So this is called the PP fuse. So it's got a little display screen right here. Let's go ahead and turn it on. Oops, longer hold. All right, so now it turns on. All right, so now what does this tool do? So it's very simple. We have right here, it says mini. So we can push this one time. It's going to go to ATC fuse or maxi fuse. Back down to mini. So what you're going to do is you're going to put in whatever size fuse that you're going to test. So we're going to go through here and we're going to just find a 7.5 amp fuse. So let's take a look at what we can find here. So here is, so we are on a 7.5 amp fuse, and this tool is telling us that we have 0.64 amps loss across that fuse. That's what the voltage drop across that fuse is, or how much amperage it's pulling. So now how does this tool work? So let's take a look at what that fuse is for. So we isolated it down to this fuse being the 7.5 amp fuse, and this is the dome light. And so this says the dome light is on, and so at this point when you're going through and you're voltage drop checking all these fuses and you get to a fuse and you check it and you find you have a voltage drop or an amperage reading with this, you look and say, oh, well, that's the dome light. And you look up and you're like, oh, all right, the dome light is on. Let's turn the dome light off. All right, so believe it or not, that's something that gets missed actually quite often. You can miss map lights and dome lights and glove box lights and things like that. So now let's look at our amp draw. We're gonna go back to our smart output, and now look at our amp reading now. Now we have 11 or 12 milliamps. Now remember I said that 50 milliamps was the maximum reading that is allowable. So now we fixed the problem. The problem was just that dome light was on. So now I forgot to show that if I left this amp clamp on here while we had the battery disconnected, because the power probe was providing voltage and keeping that light bulb on, that this would have still read 170, whatever the 700 milliamps, I think it was. So anyway, so now you can see that we have, it only says a -4 because it's, it reads the way that the current is traveling. So right now it's traveling in a negative direction. So sometimes you have to flip it around, but sometimes you can't do that. So you just have to look at the negative reading. So in this case, this is actually showing the same thing as this over here, pretty much. And we know that we have figured out this problem and fixed it. Very simple. When you have a parasitic draw, one of the first things that you want to look at is the radio. The first fuse you want to check is the radio always, and here's why. Radios are common to cause a draw. Let's say you have a CD player in the vehicle. Well, here's what happens. That CD player malfunctions. So it's constantly trying to either eject the CD, read the CD. There's always something going on with that CD, and that's the actual problem. So a lot of times, if you find a draw on a radio fuse, you pull that fuse, the draw goes away. Then what you want to do is plug the fuse back in, take the radio out, and disconnect the connector. Because a lot of times, the radio is not the only thing on a fuse. A lot of times, a fuse fuses multiple components. So you can't just say it's the radio, because it could be something else. So that's a little tip for you on the first thing to check on parasitic draw. So there's one other tool that you can use for finding parasitic draws, and it doesn't always work. It has to be a really hot system, and that is a thermal imager. So I don't have that right now. It's at work, but I have a Topdon TC004, I think, and it's a thermal imager. And so what that does is if you've got a circuit that's open, that's hot, a battery, anything at all, you can use the thermal imager and you can find the circuit that's super hot. I had a Ford C-Max one time that had a parasitic draw, and I suspected this one circuit, and I used the thermal imager, and I could see that this one relay was energized when the vehicle was supposed to be off. So I knew that that circuit was staying energized. I replaced that relay, put a new one in, boom, fixed. I could see it with the thermal imager and with the low amp probe. So that is another option. However, 90% of the draws that I deal with, the circuit's not hot enough to show it on a thermal imager. But that is another option if you've got a hot circuit. So now, what do you do when you have found a draw on a circuit? You found the fuse, you used the PP fuse, it showed the draw. How do you go about finding what the problem was? The way that you go about that is you have to research that circuit and find out what is on that circuit. How many things are on that circuit? And then what I do is I usually try to find the easiest thing to disconnect first. You don't want to go to the hardest thing, the one that's going to take the longest. You want to go to the easiest ones, unless the radio is one of those components. Oh, whoops.